two key properties that you'll definitely be asked on the exam are surface tension and capillary rise. So here's the classical picture of surface tension, insect on water, not sinking. So the reason why that's happening is surface tension is the property that the surface of the water or liquid allows it to resist an external force, and it's because of the cohesive bonds and nature of water molecules. And capillary rise or capillary action is a phenomenon where liquid can rise or fall in a narrow space, and this is because of the attraction or cohesion of molecules next to a certain tube. So in the case of water, with water you'll always have a rise. With mercury you'll always have a drop. And that's a capillary rise, that's a capillary fall. And basically that's because in water there's an effect of adhesion, so attraction to other molecules. So basically water wants to rise to separate itself from its own molecules. And for mercury, the reason why it drops down is because it wants to get closer and closer to its own molecules so it won't rise away from it. So that's why you see those two different phenomena. But it's all associated with capillary action. Now, what are the important equations? So surface tension is in units, SI units of newtons per meter, so it's force over length. In your reference handbook, it's represented as sigma, but I'm letting you know that in some textbooks, it's also represented as capital T, just in case you're looking at other sources and solving problems there. So it's a simple formula, except the handbook doesn't do a good job of defining what this L is. So L is not just a normal length, it's an effective length. So what I mean by that is, let's say I place an object in water, and let's say it's like a wire or a rod, and naturally water is going to wet it from two sides, two major sides, right? The top and bottom. So the effective length would actually be equal to 2 times the length, because you have surface tension on both sides. Everyone get that? Right? It's pretty straightforward. Hopefully. Yeah. And then what if I gave you an open ring problem? So let's say I placed like an open ring, like an open circular wire. In that case, you have an inner perimeter and an outer perimeter. So your effective length would be 2 pi r times 2. So it's actually 4 pi r. So I just want you to be aware of that, because they ask those questions on the exam, but in the reference handbook, they don't properly explain what effective length is. So that is a case where they would give you a trap answer choice where if you don't multiply by 2 for the length, then one of the answer choices will be just F over L. Now, capillary action or rise, this is the formula that's in the reference handbook. I think the only difference is instead of rho g, I think it just shows it as gamma, or it may not, but it's the same thing, right? Gamma is just rho g. So the purpose of this formula is, in most cases, you're finding what beta is, and that's the angle of what the rise is versus the wall you're dealing with. So you'll always be given a diagram, most likely, or you just have to find beta. And of course, you need to become familiar with arc cosine on your calculator, right? The inverse of cosine. And if you didn't understand this, we're going to do like a few problems, more problems than some other